Hoy es agosto 1998. So for those of you that are taking Spanish, you may know that what I just said was today is August 1998. And in 1998, in August of 1998, my wife and I went to visit Peru and Bolivia. Our first stop when we arrived in Peru was a town called Cusco. And that's what you're looking at right here. This right here is actually the Plaza de Armas in Cusco, Peru. And Cusco is the gateway to the Andes Mountains. And we stopped in Cusco on our way to go on a 5-day hike through the Andes Mountains, walking on the Inca Trail on our way up to see Machu Picchu. Now, Peru is in the southern hemisphere, and if you're familiar with the way the globe works, your whole sciencey thing, in August in Peru, it's actually winter. So, but since it's not that far from the equator, it's not super, super cold, but it was way, way, way colder than when we left home at the time we were living up here in Derry. And we went down to Peru and it was shockingly cold. We knew it was going to be cold, but it was way, way, way colder than we expected. So our first stop was to get something warmer. This hat and this sweater I'm wearing right here is all handmade out of alpaca fur, and so is the hat as well. And we bought these as soon as we got there. And actually, interestingly enough, right underneath here, these little archways, there's all vendors selling different things. And right around here in this corner, there was a woman that was selling this sweater and this hat. And I went to her and I was looking for it. But here's the problem. I don't know if you guys know this. I'm kind of big. And especially big is my arm span. I have a ridiculously long wingspan. And when I went to go get I was looking for a jacket, and I said to the woman, I said, hey, mas grande, mas grande. She goes, sí. And she picks one up and she hands it to me. She says, sí, it's mas grande, very big. And I said, I don't think it's going to work. Well, I put the thing on, and sure enough, when I put it on, the sleeves came to about here. And she laughed and laughed, thought it was the funniest thing she'd ever seen. So I said, oh, it's not going to work. She says, no problem. I'll fix it. So for what amounted to, well, it was 10, what they call nueva soles. That's what their money is there in Peru. Or it equated to about $3. She took the thing and she said, come back tomorrow, which was good because we weren't leaving for our hike for a couple days. And I came back and she had stitched on, and it's hard to see, but you can see maybe if you look close that stitching changes just a little bit, but she added a few inches of material to it for only $3. And here it is. Voila, I had this super cool looking sweater that I was able to wear and stay really warm while I was there in Peru. And it was wonderful. It was a great hike, great trip. Highly recommend it to anybody. All right, so why am I going on and on about Cusco? Why am I going on about Peru and all this, cool clothes that I got there? The big picture is that I'm in this Plaza de Armas. And this Plaza de Armas is the central square in the town of Peru. This square is a place where it all comes together. And it's not so much of anything except for the fact that today's lesson focuses on squares and square roots. So you should be familiar with what it means to square a number. That's when we take a number and raise it to the second power. And you're going to hear a little bit about what square root is all about. So, adios, amigos. I'll catch you on the end. Our discussion focuses on this idea of squares. Squaring, but not like the squares, like a town square, but squaring with numbers. And you probably recall this as being things like taking something to the second power. For example, when we have a number, say 3, and we raise it to the second power, we say that that's the same as we say 3 squared. That's what it means. It just means 3 squared. But what it means when we write 3 to the second power, it means 3 times 3. It does not mean 3 times 2. It means 3 times 3, which we know is 9. So 3 squared, we say, is 9. And you can take any number and you can square it. We could take the number 5 and square it. And 5 squared is 5 times 5, or 25. And the reason it's called squared is because if you can imagine, if you had a square and the length of one side was 5 Well, then we know that the other length of that other side would be 5 as well. And if you wanted to find the area of that square, you would just do length times width, or 5 times 5, or 5 squared, which would give you 25. That's where that word squaring comes from. We take the length of a square, multiply it by itself, and that would give us the area of the squared. So remember, when we take a number, 4, for example, and square it, it does not mean 4 times 2. 4 squared is 4 times 4, which is 16. All right, so taking that same idea of squaring something, well, what if we went the other way around and we had a square, and the square had an area of 81, let's say inches squared. So we have an area of 81, and we want to somehow find out what is the length of that one side. Well, we know that area is length times width, but in a square, we know that those two lengths are the exact same length. So we need to know what number times itself gives you that 81. Now, most of you probably can figure this out in your head, but we need to be able to write this mathematically and understand what it means. So what it essentially means is that x squared has to equal 81. So somehow we have to find out what value of x can be squared and give you 81. What number times itself gives you 81? Now, most of you guys can probably think this one through, and you're probably saying to yourself, okay, I got this. I know that x would have to equal 9. And that's true, because 9 times 9 is equal to 81. You really got to know your times tables in this one. Now, it turns out that there's another value of x that will make this true. Not just 9. So what other number times itself would give you 81? It's a tough one. I'm going to give you about 2 seconds. 1 1,000, 2 1,000. Okay, enough suspense. So the other value of x that could make this true would be -9, because if you take -9 times -9, remember negative times negative gives you a positive. So -9 times -9 could also be 81. So 9 and -9 could both be solutions for this. However, because we're talking about a square, we know that this value here couldn't actually be the solution, because we can't have a side that has a length of -9. So what we call this is something that we call square root. When we're trying to find the opposite of squaring, what that is that's something called square root. Got that? The opposite of squaring is square root. So what we're trying to find out is what number times itself gives you that other number. That's the square root of that particular number. So here's how this all works. So let's suppose we had something like this. Like if we had x squared equals 121. Well, the way we could find out what x is we'd want to take the square root of both of those sides to find out what the value of x is. Now you recall, for example, if we wanted to solve, let's say, this equation, 3x equals 12. Well, we would use the opposite of multiplying by 3 to solve and find out what x is. So we would divide by 3, and we'd get x is equal to 4. Or if you had something like this, where x over 6 is equal to 5. It says x divided by 6. The opposite of dividing by 6 would be to multiply by 6. And we get x is equal to 30. So what we have to do in order to solve this particular thing, this x squared equals 121, we have to find the opposite of squaring. Now, the opposite of squaring, we just said, is that thing called the square root. But now what we need to do is we need to think about how this all works. So what we do is we have here the opposite of squaring is the square root. So that's like if we had, again, let's do that, x squared equals 121. So what number times itself will give you that 121? Well, that could be 11 or -11. Or if I wanted to do x squared, let's see, is equal to 16. The square root there, what number times itself gives you 16? Well, it would be 4. Or it could be, I should say or instead of comma, -4. So far, so good. So what happens is every number has essentially two square roots, a positive root and a negative root. So what we do is we have another symbol. This guy right here, you may recall that one. This is a symbol that we call a radical symbol. And what that symbol does is it tells us to take the positive root of each number. So when we're taking the square root or the radical, it means give us just the positive. Let's show you how that all works. So that radical sign right there, this guy right here, means take the square root, but the positive root only. Just the positive root. This is the principal square root or the positive root. And most people, when they see this symbol, they talk about that just being the square root symbol. It is, but it stands for radical x, and it means to take just the positive root. So when we have something like this, it means just give me the positive 5. When we have something that looks like this, just give me the positive 6. When we have something like this, it means just give me the positive 2. So that symbol lets us know that we just want that positive root. We have to know that there's a negative root, but this symbol just means give us the positive root. Okay, so what happens then? What would this mean? What would that mean if we wrote something like that? Well, we know that that symbol, that radical symbol, means take the positive root of 64, which we know is 8. But then this guy right here means we want that negative. That's how we would show that we want that negative root. What do you think this means? So if we write that positive and that negative there, that means that we want both of them. That would be a positive 10 and a negative 10. That means to give both of them. Now you've noticed that so far we've been using all these types of numbers that work out really well when we take the square root. 25, we know 5 times 5 is 25. 36, 6 times 6 is 36. 4, 2 times 2 is 4. 64, 8 times 8 is 64. All these numbers that worked out really nicely. Now, every number has a square root, but most numbers are going to give us decimals when we take the square roots. And we'll get more into that maybe the next day. But what we have here is special numbers, these special numbers that when we take the square root, give us a whole number, and they're what we call perfect squares. Perfect squares are these numbers whose square root is a whole number. Now, we have a list of things here. 1 squared. Well, 1 squared means 1 times 1, which is 1. 1 is a perfect square. You notice I have the print in red. These red numbers are going to be perfect squares. 2 squared is 4. 4 is a perfect square because the square root of 4 is 2. 3 squared is 9. 9 is a perfect square because the square root of 9 is 3. 4 squared is 16. 16 is a perfect square. 5 squared is 25. 25 is a perfect square. 6 squared is 36. These numbers right here are your perfect squares. And the square root of those numbers are these guys here. Square root of 36 is 6. Square root of 25 is 5. Square root of 16 is 4. So let's keep going with our perfect squares. 7 squared is 49. 7 times 7 is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. Now you might be saying to yourself, how do I know all these? Well, you can use a calculator to figure them out, but I actually know them because I use them all the time. And this list of perfect squares, you're going to want to know them. This is a set of numbers that you're really going to want to commit to memory. Let's keep going. 12 squared is 144. 13 squared is 169. 14 squared is 196. 15 squared is 225. 16 squared is 256. Now we could go on infinitely with this, finding more and more perfect squares, but this list right here are going to be really, really helpful. I would strongly suggest you take a screenshot of this, write these down, and these numbers in red are all perfect squares. And not just knowing that 144 is a perfect square, that's important, but we also want to know that the square root of 144 is 12. So far, so good? Okay. Last thing we got to understand is that very often we're going to be asked to take square roots, something like this. Now, 30 is not a perfect square. It's a number that wasn't on our list. Now, what you're going to want to do is if you ever have any numbers that's not on that previous list and it's not a perfect square, you have to have a technique for finding the square root. So what you can do is you can use a calculator, any calculator. Now, we have a calculator posted in the resource section of our classroom. And what you're going to want to do is you're going to have to play with it a little bit and figure out how to get the number underneath this radical sign. And all you have to do is on a regular calculator, type your number, hit the square root key, and it will end up giving you what the square root of that number is. So what is going to happen quite often is you're going to find that you have a lot of these numbers that are not what we call perfect squares, because when you take the square root, they don't give you a whole number. For example, 30 is a number that is not a perfect square. If you use your calculator and you take the square root, what you get is something like 5.47722, and it goes on forever. What we're going to want to do as a general rule is always round off to the nearest tenth. That's right here. That 7 would tell us to round up to 5.5. So we would say that the square root of 30 is approximately 5.5. And you can get this information by using any calculator with the square root key. So round off your non-perfect squares to the nearest tenth. Okay? And that square roots. All right, welcome back, my friends. So that kind of sums up what you're going to be needing to do as far as working with squares and square roots. Just want to touch base on the calculator thing just a little bit more. So there will be a calculator that's going to be attached to your classroom in the resources section in case you don't have a calculator at home. And you're going to be looking for that square root key. Now remember, not every number that we take a square root of is going to be a perfect square. Perfect squares are those numbers that when you take the square root, they give you a whole number as an answer. We love those and we want to memorize that list. But many square roots are not going to be whole numbers, and that's where your calculator is going to be so important. Now, if you have just regular old calculator, there's lots of different places you could see the square root key. Sometimes you'll see it printed up here, and you might have to hit the second key to get there. Sometimes if you have, a phone, it's going to be on there, and what you're going to see is that it has this little tiny 2 right in front of it. So when you see that little check mark looking thing, if it has a little 2, that's the square root key. And Miss McCaskill has made a tutorial on how to use all the different calculators, especially the one that's set up on the website for you. So a lot of different videos for you to watch today. Today is mostly a kind of watch and learn day. There will be some work for you to do at the end, but make sure that you're watching all those videos, maybe taking some notes and really kind of absorbing all the information that's out there for you. So from Cusco in Peru, I'm going to go do some hiking. Adios, amigos.